Hi there, and welcome back. Our topic is the geology of Norway. This would be part three, landslides. The landslides that occur in Norway uh, cover the full spectrum of mass wasting, from rock falls to detachment slides to rotational slumps to other types of debris flow, uh, snow avalanches, etc. I am Robert Font, a certified professional geologist and a proud member of the AIPG. In terms of landslides, as far as Norway is concerned, the ones that are of most interest to me are the ones that are related to the country's infamous quick clays, and those that are related to the breakdown of methane hydrates. A great example of that is the massive Storegga landslide. Before we go any further, I like to make sure that we go over some definitions. The liquid limit is the water content that is the boundary between the liquid state and the plastic state in a soil or a sediment. The plastic limit is the water content that is the boundary between the plastic state and the semi-solid state in a soil or a sediment. The plasticity index is the range in water content where the soil will behave plastically. By definition, it is the liquid limit minus the plastic limit. And the liquidity index defines the consistency of a soil or a sediment. It is the natural water content minus the plastic limit, that divided by the plasticity index. Now remember that clays are disc-shaped particles, where the surface of that particle is negatively charged and the edge is more positively charged. In a flocculated clay fabric, the particles are arranged edge to face. That would be the normal condition because the positive attracts the negative. But you can also have what we call a dispersed fabric, where the particles collapse into a quasi-parallel arrangement, like it indicated in the bottom portion of the sketch. Another important definition is the definition of sensitivity. Sensitivity is the ratio of the unconfined compressive strength of an undisturbed sample divided by the unconfined compressive strength of a remolded sample of the same material at the same water content and the same porosity. What we call an extra sensitive or a quick clay, those have sensitivity values of 8 to greater than 64. Now the problem is that some clays in Norway and some in Canada, by the way, have sensitivity values of 500 to 1000. Sensitivity is related to the liquidity index. And keep in mind that the greatest loss of strength will occur in clays with a flocculated fabric where the natural water content is significantly larger than the liquid limit. I should point out to you that based on work done by Vardanega and Haig, uh, there is a relationship between the undrained strength and the liquidity index, as well as the strength at the liquid limit and the liquidity index. Those equations are shown on the right. Now here's the problem for Norway. There are more than 15,000 square miles of marine clays that are now exposed along the coastline of Norway. And some of these clays are now located as high as 600 feet above sea level. Once exposed above sea level, freshwater has leached these marine clays, turning them into the quick clays. Originally, the clays were glacially derived, deposited in a marine environment. The main clay mineral is illite, shown on the diagram here, where the units are bound together by potassium cations. So these illite clays have been leached In other words, the cations that bound these units together have been leached away, and therefore the fabric has been weakened. So the fabric is now very unstable, and like a house of cards, and it can suddenly collapse from a flocculated into a dispersed arrangement when disturbed. And when that happens, you have problems. Landsliding can occur. Here you can see some of the typical values of a quick clay near Oslo. Uh, Please note that the natural water content, 32%, is much greater than the liquid limit, which is 21%. The plasticity index is only around 5%, and that indicates that the clay passes from a semi-solid to a liquid state with only a minor increase in the water content. And the sensitivity value of 500 is a real problem and attests to the instability of this clay. If there's one case history that illustrates the quick clay instability, is that of the Rizal landslide that took place in 1978 northwest of Trondheim. By the way, an amateur photographer actually filmed it. And there is a video that is available on the internet. 82 acres of farmland liquefied and flowed into Lake Putnam. One person lost his life, 13 farms, 2 homes, 1 cabin, and 1 community center were destroyed. In addition, 3 water waves flooded the village of Lida, located 3 miles to the west on the shore of Lake Putnam, where property damage was very extensive. Now listen to this. The slide started due to an excavation of a basement at a farmhouse and the loading of the debris by the lake shoreline. What happened? Well, the clay fabric collapsed from a flocculated into a dispersed arrangements. The pore pressures increased dramatically. The clay abruptly liquefied, flowing at a velocity of 19 miles per hour, and the slide involved more than 211 million cubic feet of quick clay, forcing 40 people to be evacuated. Quick clay problems in Norway occur all the time. A more recent landslide, a deadly quick landslide, occurred in southeast Norway in November of 2016. 3 people perished. The slide had a surface area of 1.3 million square feet. The problem is that this whole area is pervaded by quick clays. The Storegga landslide is one of the largest landslides in geologic history. It occurred underwater at the edge of Norway's continental shelf around 6200 BC. The collapse involved a 180-mile length of coastal shelf and 12.3 billion cubic feet of debris. You know what that's equivalent to? That's equivalent to the size of Iceland, covered to a depth of 110 feet. Pretty dramatic. The landslide gave rise to a very large tsunami. In Scotland, the tsunami deposited sediments are found up to 15 miles inland and 13 feet above current normal high tide levels. It is estimated that the largest waves were more than 120 feet high. Wow. What triggered the landslide? More than likely an earthquake, but the result was the release of methane and water into the sediment's pore space, giving rise to an increase in pore pressure, overcoming the undrained shear strength and giving rise to the liquefaction. So what is the epilogue or the punchline? Well, Norway is a country that has a population that is smaller than the area where I live, which is the Dallas-Fort Worth area in the state of Texas in the US. But Norway is extremely wealthy from its natural resources, as we talked about in part 2, and mass wasting is a major headache, a major geological hazard. Well, that's it. that concludes our discussion of the geology of Norway. I hope you have learned something and you have enjoyed it. Thanks and goodbye.